Good morning, students. Today we'll talk about the truth table, Boolean expression, equivalence of Boolean expression, and De Morgan's law. So, what is the truth table? The truth table is the mathematical expression or a tabular expression that have all the combination of values for the input and their corresponding output. It is a mathematical table that shows all the possible outcomes that would occur from all the possible scenarios that are considered factual. Hence, the name of the truth table are usually used for the logical problem as in Boolean algebra and electronic circuit. The truth table shows the result of a Boolean expression. For example, if we are having two variables, if we have all the possible combination of these two variables, all the possible combination for these two will be 0 0 1 0 0 1 and 1 1. So corresponding to these two variables, suppose I have to calculate a dot b, then this will be calculated as 0. The values will be 0 0 0 and 1. This is the truth table for the function a dot b. For a dot b, this truth table have all the possible values of a and b, and from here we can conclude that the value of a dot b will be true only when the value of a is true and b is true, otherwise it will be 0. Similarly, if we take a plus b, the a plus b will give the value true only when we have only one value as true, like a b, the final we are having 1 for the values. If we have only one input as true, the finally will get the true. These are the conclusion that can be drawn from any truth table. Example, this is the truth table for a dot b that we have given here. The next we are having is the Boolean expression. So what is the Boolean expression? The Boolean expression is an expression that is used in the programming languages that produce the Boolean value when evaluated. A Boolean value is either true or false. A Boolean expression may be composed of a combination of Boolean constant, true or false, Boolean type variable, operators, or functions. For example, if we are having any Boolean expressions, a Boolean expression is composed of Boolean variables. For example, this xy plus x bar y. This is the Boolean expression. Here x and y are the Boolean variables. A Boolean variables means a variable that can have two values, either 0 or 1. So if we combine the Boolean variables in form of expression, this is called the Boolean expression. The next we are having is the equivalence of the Boolean expression. Equivalence, like we have to show the Boolean expression are equal or not. We are having the left hand side and the right hand side of the Boolean expression, and then we have to prove we can prove that with the help of truth tables if the Boolean expressions are equivalent or not. So how we'll prove that? We'll check if the truth table of give the identical values for each column for any Boolean expression in a truth table, then they are equivalent, otherwise they are not equivalent. For example, here we are having the Boolean expression. We are having this a dot b a dot c, this is equal to a plus bc. So we have to prove this is identical or not. For that, we'll take the left hand side and we'll draw the truth table for the left hand side, this one. And then we'll take the right hand side and we'll draw the truth table for the right hand side. And as we can see, the values in both the columns are same. That shows the equivalence of this Boolean expression. That shows these Boolean expressions are equivalent. So this is how we can prove the equivalence of two Boolean expression. The next we have to prove the equivalence of this Boolean expression. So the same here, we have calculated is we have calculated the left hand side. This is left hand side. We have draw the truth table for this. This is the right hand side and we have draw the truth table for this. In the truth table we have taken all the possible combinations like A, B, C. And here we can see that these two expressions are not equal. For example, left hand side is not equal to right hand side. That means these two expressions are not equal. They are not equivalent. So we can prove that with the help of truth table. We have three values, like suppose we are having three combinations. We have to draw the truth table. For how we'll draw the truth table? For C, we have to for A, B and C we have total 8 combination. How? 3 variable, to the power 3, 8 combination. So how we will make these combination? We'll make like 0 1 0 1 0 1 and 0 1. This is the trick how we can make the combination. Then for the second variable, 2 zeros 2 1 2 zeros 2 1. For the third variable, 4 zeros 4 1. And similarly, if we are having the 4 variables, we'll add the another variable here, D, and for that we are having 8 zeros and then 8 ones, and we'll add in this side like this way, 0 1 0 1 and like this. This is how we can create the combinations. The next we are having is De Morgan's law. Okay, this is the De Morgan's law. But De Morgan's law states that a plus b whole bar will be equal to a bar plus b bar. A dot b whole bar will be equal to a bar dot b bar. This is the truth table for the De Morgan's law. This is the truth table we are having is for the De Morgan's law. But we have calculated in the truth table a dot b whole bar. This is the a dot b whole bar. And then we have calculate a bar separately, b bar separately, and finally we have calculate a bar plus b bar. And we can see the values of a dot b whole bar and values of a bar plus b bar are same. This shows the equivalence of this De Morgan's law. From the duality, we can also prove that we can also prove the second part, like a dot b bar, this will be equal to a bar plus b bar. The duality says a plus b whole bar will be equal to a bar dot b bar. This is the De Morgan's theorem, and we can prove this with the help of truth table. This De Morgan's theorem is applicable for n number of variables. For example, here we are having 3 variables a, b and c. A, B and C. If I am going prove that like a plus b plus c whole bar, this will be equal to a bar dot b bar dot c bar, or a dot b dot c whole bar will be equal to a bar plus b bar plus c bar. We can similarly we can prove it for the 4 variable, for 5 variable, or up to n number of variable. This is applicable for n number of variable. This is the De Morgan's theorem. Thank you. That's it for today. In the next chapter we'll discuss about the SOP form and POS form of the